Okay. Hello. So we're gonna pretend that we just started now. Sorry, I thought I broke my necklace. That's a good start to the session. So we're gonna start by going through chapter 16. I'm gonna basically fill out this handout for you guys in like supersonic speed, and then Katrina is gonna add all the stuff for Dr. Roche's class specifically. And so all my kids, you can just fall asleep during that time. We won't be offended. And then in the meantime, as always, I'm gonna just close up my chat, and Katrina's gonna be in charge of the chat. And she's gonna be trying her best to like answer questions, but if she doesn't see you immediately, don't be offended, please. All right. So, first things first, if you're one of my students and you've been to my SI sessions, I hope you're able to do this in your sleep. So, an acid catalyst affects a reaction by making acid makes the electrophile more electrophilic. Wow. Oh my goodness. Ta-da. It makes the electrophile more electrophilic, and the base is going to do the opposite. It's going to make the nucleophile more nucleophilic. I'm so determined. There we go. All right. Also, sorry if my iPad screen is like today. I don't know what its deal is. She acts up sometimes. All right, so the carbonyl in chapter 16 and 17 is always going to be the electrophile. So in chapter 16, these are called nucleophilic addition. Excuse me, I thought I was going to sneeze. Nucleophilic addition reactions. Chapter 16 is called nucleophilic acyl substitution reactions. 17. So 16 is addition, 17 is substitution, but in either case, the carbonyl is always going to be the electrophile. So there's at least one constant for you. All right, so now, one, because nobody cares, and two, because we don't got time for that, I'm not going to go through the whole entire mechanism for all of these guys. We're just going to do like the simplified version. So if you're someone who needs the whole mechanism, you can check out the YouTube videos from my sessions, and I did actually upload them all, so don't come for my throat like you did in my SI session. True story. So the Gemdial reaction, aka the hydrate reaction or the hydrolysis, reaction. In this one, we have a ketone, and I'm going to do a separate one for the aldehyde because the equilibrium is actually different. So the ketone can react with water, and I'm actually going to be more general here, actually. So it can react with acid or base, and it's going to turn into a Gemdial. And this is called a Gemdial because there's two alcohols on the same carbon, which is called the geminal position. So the equilibrium for this one is going to heavily favor the ketone. So we're going to get a little bit of Gemdial. Whereas in the aldehyde version, equilibrium is going to favor the Gemdial. Sorry, I'm trying to write and think at the same time. It's going to favor the Gemdial because aldehydes are super duper reactive. And so we're actually, like when we think about reactivity, ketones are better than Gemdials, but Gemdials are better than aldehydes. So think of it in that order, and hopefully this equilibrium will make sense. Also, something I forgot to mention, this is completely my bad. All of the chapter 16 reactions are reversible. All of the chapter 17 reactions, I don't know about what Dr. Roche said, but according to Dr. West, they're not reversible.
They're not necessarily reversible according to Roche, but there's ways to undo them.
Like, okay, but it's not like
a different reagent.
Oh, okay, so okay, cool. So according to Dr. Roche, he apparently has given you some reagents that you can go backwards with, but it's not reversible. Yeah, don't worry too much about it. Alrighty, so now Gemdial versus Acetalketol. So they're kind of similar, except in the Acetalketol reaction, we're going to have a ketone or aldehyde. And that ketone or aldehyde is going to react with an alcohol. So this is any R group on an OH. And this time it actually does matter whether we have acid or base. So I'm going to show you in acid. If there's acid, we're going to have an intermediate that looks like this. And then we're going to have a product that looks like this. So this is the hemi. In this case, it's the hemiketol. And here we have the ketol. So what if we had no catalyst or we had base catalyst? So if we were to have some alcohol with base or no catalyst, we would end up stopping at the hemiketol or hemiacetal. And just in case anyone's like, wait, what's the difference? So the hemi has an OH and an OR, whereas the ketol and the acetal have two OR groups. So that's the biggest differentiator between the two. If there's an OH present, it's going to be hemi. And we only make it to the final product if we have acid. And another way he can ask you a question about this is he can say, like, which of the following reagents would an acetal be stable in, right? So acetals are unstable in base. No, I'm so sorry. Acetals and ketols are unstable in acid because they're reactive in acid, but they are stable in base, so they are unreactive in base. If you're anything like me and you swap those words up all the time, I would definitely write it down.
Can you repeat that?
Hydrogen.
Yes, I did. And yes, I definitely can repeat it. Okay, so acetals and ketols are unreactive in base because they are stable in base. However, acetals and ketols are reactive in acid because they do react. They're unstable. That was a weird way to say that, but here we are. It's fine. All right. This is getting a little bit cluttered for me, so I might make a new page. I'm absolutely going to make a new page. This is fine. Okay. I hope nobody was too committed to that page. So the next one we're going to talk about is the imine reaction. And in this reaction, we're going to have an aldehyde or ketone. It could be either. And it's going to react with a nitrogen that has two hydrogens and an R group. So we call this guy a primary amine. And it could have acid or base catalyst. So people for this chapter always ask me, like, how do I know which reaction is which? And I'm basically going to go through and highlight that for you in blue. So if you see an aldehyde or a ketone with acid or base and a primary amine, that gives you straight away imine reaction. And the way we get the product is we keep this bottom half exactly the same. We double bond to nitrogen and we keep our R group. Ta-da! Simple as that. We do get rid of the hydrogens. You don't have to worry too much about why or where they go. Just know that they do disappear. Ta-da! So now the next one that's pretty similar is called the enamine reaction. I don't know why. There we go. So the enamine sounds kind of similar to the imine, and that's because it is kind of similar. So we're going to have an aldehyde or ketone, and this time we're reacting it with, gasp, a secondary amine. You guessed it. This is when there's 2 R groups instead of 1. And again, we can use acid or base, and we can use a ketone or aldehyde. So this one, I make jokes, but this one is a little bit different. So when we have the enamine reaction, we're going to keep the bottom part the same. We're going to single bond to nitrogen. Nitrogen keeps its 2 R groups. And we're going to make a bond to one of the alpha carbons. So let's say, actually, I'll do another example for you. I'm going to scroll down. So let's say you have something that looks like this, right? You have alpha 1, you have alpha 2. How do you know which side to make the double bond on? Whichever side is more substituted. So you go like this, fill in the nitrogen, and then you're going to say, all right, this guy has 1 hydrogen, this one has 3. The side with the least number of hydrogens is the side you want to make your double bond to. So we're going to get rid of this and form a double bond. Ta-da. The other thing to know is enamine reactions can not happen without an alpha hydrogen. So these alpha hydrogens, if there's not one present, you cannot do this reaction. So if I gave you something like this, we cannot do the reaction. And then I always give this example because people are like, well, this is a hydrogen. Yes, it is, but it's on the carbonyl. It's not the alpha carbon, so we cannot steal that. I went through this kind of fast, but that's the point of the exam review, right? We're going to put all the stuff we don't need behind us and focus on the quick versions. So let me zoom out just in case anyone missed anything. I'll give you approximately 20 seconds-ish.
Secondary, primary.
Tell us, please.
So do you see how in the imine, the I kind of looks like a 1?
Yes. You know, Chase actually told me that you told her about that.
The enamine has 2 letters in front of the amine portion, so that's how you know it's a secondary am. I'm a dumbass.
No, you're a genius. See, everyone's gonna pass just because of you. Oh, yawn. All right, moving on.
Somebody's asking, how do you know where the double bond goes in the enamine?
Okay, so the double bond is just going to go to the more substituted side. So if you had a symmetrical ketone like this, you pick either side. If you have an asymmetrical ketone like this, you pick whichever side is more substituted.
Sorry.
No, it's okay. Ta-da. All right. So you want more substituted. So you want less hydrogens present. Hydrazone. So the next one we're going to talk about is the hydrazone reaction. Once again, we have a ketone or aldehyde. Wow. You're never going to get sick of hearing that. And then we have this guy, and we have acid or base. Bam, 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 bam. So what the heck is this guy? Well, he's called hydrazine. And essentially what we're going to do is we keep the bottom part, as always, double bond, and we fill in the nitrogen. Ta-da! And this guy is the hydrazone. So if you're a person who like sees patterns, what I want you to be seeing is most of these reactions, save the acetalketol and Gemdial reaction, are going to take this nucleophile and just replace the oxygen. Okay. So the hydrazone reaction, sorry, I'm adding a page and it likes to be finicky. A lot of people are like, but wait, Rosemary, how do we know which is the product and which is the reactant? And I'm like, hey guys, look, ready? The hydrazine goes into the reaction and the hydrazone comes out of the reaction. Or if you're anything like me and that's too boring for you, you could think, okay, the hydrazine goes in and then the hydrazone, we're done. Like, oh, snap, we're done. You're done. You're done. If you don't get that reference, you can leave. No, I'm totally kidding. Sorry. I lost my, I wanted to turn the chat on while Katrina was gone. There we go. Are you? Good soup. Okay. So, and is this the one with excess? Yes. So we're going to do the excess one now. So we could have this exact same thing, except he could say excess on the bottom here. And bam. So if he gives us the hydrazine and he gives us excess, it's going to be really weird looking. So you're going to keep this bottom part, double bond N, double bond N. And now this second nitrogen also has this guy. So you're essentially just slabbing two ketones together and like connecting them with a nitrogen, if that makes any sense whatsoever. All right. And the last one of this set is the phenyl hydrazone. And it's going to be very, very similar to the one we just did. Again, ketone or aldehyde. And you're going to react with, I'm going to make a super long line because this one is ugly. So you have H2N, NH, and I still surpassed the line because I'm that good. And we have acid or base. Yes, we are, Eric. Don't jinx it.
Yes, please do.
Phenyl hydrazine. And we're going to make phenyl hydrazone. And what I want you guys to be very, 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 very careful about, because everyone, for some reason, wants to use the middle nitrogen and they want to sandwich it. But we don't like that. No, no, no. We want to get the end nitrogen. We want to get the nitrogen in the middle. And then we want to get the phenyl on the end. And yes, I will scroll up and zoom out at the end when I'm done with this one. But this is the I lied. It's the phenyl hydrazone. Bam. Bam.
Rosemary, when I took Orgo 2.
You had like Walmart rosemary. Is there a special name for the excess? No. I mean, I'm sure there is, but we don't care about it. They're not going to ask you about the name. Also, I don't know what's going on with my hair situation. My hair is like soaking wet right now and it's like plastered to my head. And then to everyone who's like, it's this simple and we could have gone through this whole chapter in like 25 minutes, but you decided to show us the reaction mechanism in like 47 steps for each one. Trust the process, okay? Trust the process. It helped you. I know it did. I've lost it. It's gone. Okay. Any questions, comments, or concerns? Because we're pretty much done with like the big first chunk of chapter 16. We're going to do the Wittig reaction. Ignore what I just said. Ignore what I just said. So we have the Oxime reaction. So this is going to be a ketone or aldehyde. And this is actually the only one, in my opinion, that makes sense, the naming of it. So we have I wish I would show it to you before I started naming it. That'd be cool. HO and H2. And this guy is a hydroxyl amine. Wow. So we go bam, bam. Nope. Bam. And again, acid or base. I'm going to get so tired of writing that. But I know if I don't write it, someone's going to be like, can we do it in base? And I'm like, that's a valid question. But I don't want to answer it. All right. We'll address that again at the end. Put a pin in it. Let's put a pin in it. All right. So we're going to double bond. Again, I want to drill this into your brain. Bye, Eric. I'm going to miss teasing. Who else am I going to blame things on? Darn it, Eric.
Good, Danny.
Oh, that's true.
Actually,
both of them left. How will we ever get through? Maybe we'll get through a session today. No, I'm kidding. I'm so sorry. I'm just messing with you. Okay. Anyways, so this is something I really want you guys to know. A lot of people mess this up again, and I get it. The nitrogen is always added to this. The oxygen is going to be the sidecar. The nitrogen is attached. Oxygen to the side. Now you'll never forget. Okay, so now for real, we're done with this big first chunk. We're going to move on to the Wittig reaction, but now you may ask questions.
it's the side piece.
Yes, O is always the side piece. Especially to carbon. Carbon is a hoe.
Carbon is such a hoe.
You know, in my 9th grade science class, that's how my professor taught. Well, not professor. She was like a 9th grade teacher. But she was like, yeah, carbon is a skank. And I was like, oh, okay. I was like, I am 13. Like,
You need to slide in because there's
oh my gosh. I'll bleep out skank. Everyone loves carbon. Yeah. Like that one toxic X you can't get rid of. I'm kidding. Katrina, what do you need to tell us? Look, Sarah, I am happy. It's all that matters. Okay, anyway. Moving forward. Yes. Okay. So I'm trying to decide. Yeah, okay. Yeah. What would I do without Katrina's logic?
on the pH scale because you're basic AF. Oh my That's really good. I like that.
Damn. Damn, girl. Damn. Okay. Back to concentration mode. All right. I give that. That wasn't even funny, Simon. I'm kidding. I'm sorry. If I start laughing, I'll never stop.
Yes, guys, please stop with the jokes.
I'm trying to close the chat so I would. Oh, I don't know what I did, but I closed it. Okay.
But you didn't close out of the meeting, so that's the important part.
Yeah.
Okay.
Yes. Okay. So the Wittig reaction. I'm not even going to show you the box. I'm going to show you the rosemary method. But the first step is making the illid, aka the Wittig reagent. What was that? I don't want to know. Okay, so we're gonna have some kind of alkyl halide. And this reaction is going to involve 2 steps. So whenever you see these 2 things like in order consecutively, you know it's this reaction. So you're going to see PH3. This is also called triphenyl phosphate. It could also be written like PC6H5 3. So if you see any of those things, this is what you're talking about. And the second thing is C6H5Li. And that looks like so. Right? And it's essentially just a strong base. So what happens, you might ask? Well, in the first step, we're going to yeet out the halide, the halogen, and we're going to attach a PH3 and give it a positive charge. And in the second step, we're going to yeet that hydrogen and we're going to make a double bond. So we get bam, bam, PH3. Ta-da! And at this point, I'm leaving. Sorry, I don't know why I just did that. We have a resonance structure for this guy, and it looks like so. So just know that there are 2 resonance structures for our pal, the illid. So this is the Wittig reagent. We haven't done the Wittig reaction yet, so just to be clear. But now let's do the Wittig reaction. And at this point, it might as well just be called the Rose reaction, but we're working on the legal side of that. So okay. So the rosemary method involves us, it requires us to get back in that Halloween headspace, right? So I want us to think back to last week, right? And we're going to pretend that we're Dr. Frankenstein, right? So the illid reaction can happen between any ketone or aldehyde. So ketone or aldehyde. And we're going to say R1 and R2. And then clearly double bond to O. And then we're going to react it with the illid. So the illid, as we just saw, looks something like this. And I'm going to call it R3 and R4. Bam. And then there might be whatever reagent in there. We don't care. Maybe there's acid and base, whatever. So what we're going to do is we're scientists, right? We want to push the boundaries of science and nature. So what do? We cut off their heads. Bam, bam. Yes, off with his head. So once we cut off their heads, I'm sorry, I just saw something pop up at the bottom of the screen. I have no idea what it's supposed to mean, but I'm not even gonna, I'm just gonna move right past it. So off with their heads. And since we're feeling particularly mischievous today, we're gonna see what would happen if we stuck two heads together. So I'm just gonna go bam, bam. What a rebel. It's useless. Doesn't do anything. We don't care about it. So that was a bust. But now we've lost both of our heads. So we're just stuck with a lousy pair of arms and a lousy pair of legs, right? And like half of a trunk of a body, right? But wait, what if we try and make something that doesn't have a head? So let's make a molecule creature that is just arms and legs, right? And so I'm just drawing it out and having a good time watching Katrina cringe. Ta-da! So this is the important product. We made an alkene. And I need you guys to note something, right? I usually get up to do this demonstration, but like I'm confined right now. So my arms can go this way or they can go this way, right? I can go forwards or backwards. Same thing with my legs. My legs can face forwards or backwards. So when I'm putting my monster together, I can either put the arms on this way and the legs this way, or I can mix and match it a little bit. So R1 and R2 can flip-flop. R3 and R4 can flip-flop. But like we're pretty freaky. We put two heads together, but we're not going to exchange an arm for a leg. Like that would just be too cruel. So you cannot mix R3 and R1. So you can only flip over what's on the same carbon. You can't switch across carbons, if that makes sense. So these are your two products, and the alkene is really the only one that matters. We don't care about OPPH3. Yeah, some of y'all's parents are going to be real worried. Like, is this what I pay for with your tuition? Like, yes. All right. Bam. Any questions? Not about the state of my sanity? And say it like a... It's gone. Oh, okay.
Somebody said something.
It's for education.
What's the name for that? Besides the rosemary method?
That's the Wittig reaction. So this is the real title for this.
No, because you said the top one's the yellow, but what's the bottom part mean?
So this is the illid. This is the Wittig reaction. So this is
Oh.
making the Wittig reagent. This was actually using it.
Okay, thank you.
In 8th grade, my teacher told this guy he was going to die like Newton and die a virgin. And then I told them how, like, it could have been worse. He could have been Darwin who married his cousin and had like 13 children.
See, the funniest part about that is that he was like the genetics guy, like evolution guy.
He knew about natural selection, and I swear it was to test his hypothesis whether or not like inbreeding was a good thing. And he even said it in his book. He was like, "Some of my children are sick. I wonder if it's because I fucked my cousin."
He's done. He's done.
Okay, guys, forward. Yes. Yes.
Okay. So yeah, that's pretty much it for chapter 16. So I think I'm gonna pass it to Katrina. And there's I'm gonna have Katrina do her thing, and then we're gonna come back and we're gonna do the naming ones because I've done this like a bajillion times.
Okay, hold on. Guys, I'm getting my shit together.
Joe said SMH be like Mendel and be a monk. I'm gonna shave my head and turn into Gregor Mendel. It ain't much, but it's honest work. It do be like that.
When your iPad doesn't want to work with you, it's just like, let's not stop your video. Okay. Can everybody hear me okay?
Oh, let me turn my. Oh wait.
Oh no, I'm using your computer.
Oh, okay, cool.
Yeah. Because I don't have like that awkward feedback where it's just all like staticky and you're just like, what is that?
Yeah.
Okay.
Here, let me stop sharing.
Oh, I just took it.
Swaggy.
I just stole it. Okay, everybody. So, for my Roche people, for some unknown reason, he's been focusing on synthesis of things as well. I don't know why. This has never happened in the past. But yeah. Katrina's background has a guy. That's my boyfriend. Yeah. There is a guy in my background. Okay. So, I broke this. What just happened? My screen disappeared. No.
It didn't want to.
Screen sharing. So confused. What is happening? My thing is just not working anymore. Okay, let's just.
Do you need like permission to share?
No, it just kicked me out for some unknown reason. It was like you can't use audio and this at the same time. I'm like, I'm not even connected through audio. But whatever. Okay, that's fine. Okay. All right. So in this guide I made for you guys for chapter 16 that I'm going to re-upload, here's every single thing that you need to know about synthesizing aldehydes. So there are 3 different ways to synthesize an aldehyde. You can either do these oxidation reactions, which we learned about in chapter 12. So yes, it comes back to bite us in the ass, but
Suddenly I love Wes.
yes. So you could use Swern, aka DMSO, or PCC. Those are the 2 ones that we mainly see. At least that's what Roche has been using. So all we do is we take a primary alcohol, we use one of those guys, and then we create an aldehyde. And this is via oxidation. You don't need to worry about what the actual reaction is called. Just note primary alcohol plus either DMSO or PCC equals aldehyde. Okay? The other way you can do it is alkenes to aldehyde. So you start out with a double bonded carbon to carbon bond, and then you do ozonolysis. Okay, ozonolysis was from Orgo 1, so I'm really annoyed that this came back, but it's fine. So this is your reagent here. It's O3CH2Cl2 over Me2S. Don't worry too much about that. When you see O3, just be like, oh, ozonolysis. So all you have to do with that is be a crazy person who chops off the double bonds. So you're going to essentially come in, chop the double bond in half, and then you pop on an oxygen with a hydrogen, because there's a hydrogen here, right? This hydrogen stays the same. Hold on, sorry. Let me zoom in. Oh, that's a
Sorry about that.
Okay, you're good. You're good. There's already a hydrogen here, and there's already a hydrogen here, so that doesn't change. But you're essentially cleaving that double bond in half, and you're adding on this oxygen to both heads of that double bond. Same thing's happening down here. You're cleaving this in half, and you end up with a ketone, and you end up with a, I think it's specifically called a, no, that's actually not acetone. I can't think of the name. But anyways, it's just 2 hydrogens bonded to a carbon. There's
Formaldehyde.
Formaldehyde. There we go. Sorry, my brain cells don't want to work today. So these are just ways to make aldehydes, but do note that there's always going to be 2 products when you're doing ozonolysis, because you're cutting that double bond in half and you create these 2 products. Okay. Once again, don't worry too much if you're not getting this right now. It's going to be on canvas for you guys. So, and then the last thing we could do is take an acyl chloride, an ester, or a nitro, and use one of these 2 reagents, either LiAlH with terbutoxide or Diol, not Diba, Diol. Okay, this is only for Roche, yeah. Hopefully Wes doesn't throw this crap at you. That would be dirty. So acyl chloride reacts with our LiAlH to form an aldehyde. Our esters and nitriles both react with a Diol to create the aldehyde. And the last thing you need to know about synthesizing things is how can we take a carboxylic acid and turn it into an acyl chloride? These are your reagents, SOCl2, PCl3, and PCl5. As Roche, if you guys weren't there for that lecture, Roche called me out for this one because I told him PCl3 and he goes, that will work, but like SOCl2 is better. And I'm like, all right, whatever. So he will likely give you SOCl2. So when you see SOCl2 and you see a carboxylic acid, just know it's going to turn it into an acyl chloride. That's just it. Okay. I will, you guys don't need me to screenshot this because you guys can print it out. Okay. Synthesis of ketones is a little bit longer. There's 4 ways that you can make a ketone. So once again, you could take the alkene to create a ketone via ozonolysis. Note how it's the same exact reagent from earlier with that O3. So you're still doing the same thing. We're cleaving the double bond in half. And then we just create these 2 ketones. Well, this is an aldehyde and here's our ketone. Okay. So just cut the double bond in half and pop on some oxygens at that end that you cleave. All right. You can also take something called an arene, aka just an aromatic ring, in this case benzene, and you can react it via a Friedel-Crafts acylation reaction to create a ketone. I know you guys probably want to like chop off my head right now, but don't do it to me. If it was up to me, I wouldn't test you guys on this. So of course our reagent, if you guys remember from chapter 15, is this RCOX over AlCl3. So here is that reagent right here. This is our acyl group. So we're just going to pop that guy onto this benzene and we end up with this. Note how this is a ketone. This is a more specific example where we actually had an R group and that's what you form. You are very much welcome, Stephanie. I knew that this was a lot of crap to go through in the book, so I just kind of organized it hopefully a little bit better than what the book has. And I know a lot of people don't want to ever open the textbook. So, all right, secondary alcohol. You can also use a secondary alcohol to create a ketone via Swern oxidation. This is the reagent. So Swern just means DMSO. So when you have a secondary alcohol reacting with DMSO, you form a ketone. Remember, to create an aldehyde, you need a primary alcohol with DMSO. So, yeah. And then finally, you could take a nitrile and turn it into a ketone. These are your reagents. This is Grignard, right? RMGX. Grignard did not leave, unfortunately. So we can use Grignard followed by H3O plus to create a ketone from a nitrile, or we can use this organometallic whatever. Basically R with a lithium, and then followed by H3O plus. Both of these will basically yield the same thing. You're just creating a ketone. So all you need to do is know nitrile plus one of these guys equals ketone. Don't need to know the reaction mechanism. Thank you, Joe. Don't need to know the reaction mechanism. Just know when you see this reagent, you see this starting product, you create this. Okay? All right. So that was just your synthesis. I apologize. So this is the synthesis from your textbook that Roche wants you guys to cover. I'm keeping this stuff in here. This is literally labeled Chapter 16 Reactions from SI. This is the handout, essentially just rewritten for you guys. So this will be all there. Everything's there. Here's even the Ilin and the Wittig reaction. And here's my other Chapter 16 notes. So basically, if you have an aldehyde or a ketone, you can react it with HCN to create something called a cyanohydride. Literally disgusting. But if you treat a cyanohydride, so this thing here, this specifically is a cyanohydride section with a CN on it. You can treat it with H2SO4 to create a carboxylic acid. So this guy here, this CN, will become a carboxylic acid. Or if you reduce it with LiAlH4, this CN will then become a primary amine. I know that's a lot. Just know what this is going to be your starting product. These are going to be your reagents, and this is what you create. Okay, just break it down. I promise you, this is like straight memorization, unfortunately. But yeah, I have seen Roche use this in a couple of his practice problems, and I was like, oh, why? Why
I had a
would you do
question.
this? Yes.
So you said for the LiAlH4, You said it
Mhm.
becomes RNH2 and it keeps the alcohol.
Yeah, the alcohol stays there. What we're reducing is this C. So this CN will essentially get switched out with a primary amine.
So it just be NH2 with the R group on it, or just NH2?
Yeah, whatever the R group is on there. So you're going to create an NH2 with an R group on it, since that's a primary amine.
Okay. And then the same thing happens with the H2SO4. We just keep the alcohol.
You keep the alcohol because that's what creates the carboxylic. So yeah, you just replace the CN with a carboxylic acid. I'll try and pull the one from the textbook for this one because I think they do the actual reaction mechanism, and I'll grab that and put that in here before I upload it for you guys. When do you need a protection group for these kinds of reactions? So when I was gonna put this in here, but it would take forever because it's a multi-step reaction that I would have to show you guys. But basically, Grignard is the only thing that we really have that might react as a base instead of a nucleophile. So the only time that you'd ever need to use a protecting group is if you're doing a Grignard reaction and you see an acidic proton. That's when you need to put on a protecting group. So when you see Grignard, so RMGX, some form of that, and you see that there's an acidic hydrogen on your molecule, know that you're probably going to have to do a protecting group before you do your Grignard reaction. Okay, there's 3 more reactions, and I apologize. The Baeyer-Villiger oxidation reaction. So the reagent for this is a peroxy acid. This is your formula for a peroxy acid, your basic one, and I drew out what it looks like. Essentially, all you need to know about the Baeyer-Villiger oxidation reaction is that it takes a ketone and it turns it into an ester. Okay? So the area where you add that oxygen between the R groups is dependent upon what that carbon is. Is it primary? Is it tertiary? Is it secondary? The order goes hydrogen, tertiary, secondary, aryl, which just means it's part of a ring, and then primary, then methyl. Okay, so it kind of follows the same thing as a carbocation. It's just that you start with hydrogen first, and then it goes tertiary, secondary, primary. But in this case scenario, it didn't matter where we bonded it to because this ketone was even on both sides. So ketone to ester. And I do believe I went over this in SI the other day, so yeah. And if not, I will add it in on Monday in the recorded one if you guys really need it. Okay.
Yeah, it's been a 1 mole situation.
The 1 mole situation.
Yeah.
We don't have to worry about the moles for the Baeyer-Villiger oxidation. That was more like the acetals and the ketols.
Okay.
Which, yeah. So you don't have to worry about that for the Baeyer-Villiger oxidation reaction. Okay, so the Wolff-Kishner reduction. I did not have to learn this when I took Orgo 2, but now you guys are having to learn it, and I apologize. Essentially, this is all that happens. You're going to take a ketone, and you're going to get rid of the double bonded oxygen. That's it. Ketone, go bye-bye. And there's just a carbon left there. So your reagent for this is a hydrazone followed by KOH and heat. And that is what you end up with. You just form this thing here. So the ketone goes bye-bye. Here's the actual reaction mechanism, which is going to be on there for you guys in case you are a reaction mechanism heavy person. And then that brings us to our last one. The Horner Wadsworth Emmons reaction. I feel bad for whoever's scientist's name that was. And I also feel bad for the students that had to learn that stupid name. So the reagent for this is the phosphonate ester, which looks like this. This reaction does the same exact thing as the Wittig reaction, okay? Same thing. The only difference is the reagent that you're using, and that the Wittig results in a Z-alkene isomer, while the Horner-Wadsworth-Emmons reaction results in a E-alkene isomer. So some of you guys might be like, what the does that mean? I'm getting better at bleeping things out, by the way.
I noticed. I was like, look at you.
I think you guys can fill in the blanks. So what we're talking about with the E and Z alkene is based on, okay, so we're looking at our double bond, right? Are the largest groups, are the groups that get priority on the same side or opposite sides? If they're on the same side, they are Z same, so it creates the Z alkene. If it's on opposite sides, they are everywhere, so they are the E alkene. In this case, this is the E, right? Because they're on opposite sides. So if this was the Wittig reaction, you would mainly have the Z isomer. So both of these groups would be pointing up this direction. I apologize that you guys need to know that, but that is the only, I don't even want to say those are the only things that are added. This is what is added along with what we already covered in SI for chapter 16. And this will all be on Canvas for you guys. And if you guys have any questions or concerns, you can either ask me now, or you can email me over the weekend, or ask me in SI on Monday. So any questions or concerns before we start chapter 17? I'm going to take the awkward silence as a no. And yeah, we'll move on so we don't waste too much time.
Woo!
Okay, I'm going to stop sharing.
Okay. First of all, Katrina's a champ. And beautiful, wonderful, magical work of art. I have never been happier to be working with Dr. West. I will be completely honest with you. Stay safe, y'all. West students, we're gonna go over here. We're just gonna, I hope you dissociated through that. Some people were like, what is this?
Worry about it.
It's not for us. I literally today showed Dr. West like some of the practice problems and was like, hey, is this gonna be on the exam? He was like, no. And I was like, that's my homie. See any interesting TikToks, Abel? Okay, I'll stop. Okay. I want to make tacos. Wow.
Joe, I want some tacos.
I love that you see Orgo TikToks. Excuse me. I have a TikTok account where I literally just said I was going to make Orgo jokes, but then I've just made like 3 jokes. If this would load. The amount of please send me some TikToks. Oh, she's talking about tacos. Never mind.
Tacos.
Joe, why
What, you don't want tacos?
way?
I want tacos.
I'm gonna tell you something, and everyone is gonna like dox me on the internet
You
for
don't
it.
like tacos?
I don't love tacos. Like, I can't eat tacos from like an outside place. I need it to be like from my house, and I need to make it, and it can only be hard shell. I don't know why I keep like raptor clawing. Yeah, it's just, I don't know. I used to hate pizza, and people bullied me so much that now I'm weird, period. I know. I'm sorry. Yes, hard shell is superior. Also, I will just tell one story and then I'll get back on track. So I went to a Mexican restaurant once, and I'm really bad at eating things. I just am so bad at existing. And the lady at the place, the man, the waiter, was like, he was like, what do you want? And I was like, oh, can I just have a salad? Like a Caesar salad? And he looked at me and was like, wow, way to take advantage of the Mexican restaurant, and like rolled his eyes, and I was like, I'm being bullied. It's traumatic. I go there for the mojitos, if we're being honest. Dorito tacos don't count as tacos. What is a Dorito taco?
You know, like Taco Bell has Dorito tacos. Like
Oh.
the shell is like a Dorito chip. It's not great
You're on thin ice,
to
Rosemary.
me.
I will eat the
I'm
ones
sorry,
you
David.
made. Hey, David's my man.
David just said Doritos tacos are really good, so I was like,
Oh, I
don't know if I agree with that one.
I just learned about Dorito tacos like 15 seconds ago, so I have no opinions on them, but you know, it'd be that way. All right. Anyways, so I decided to give everyone like a minute or two. You know, I've never been to Taco Bell.
I mean, you don't like tacos, so
Yeah. I've been to Rocco's Tacos though. I had a quesadilla.
By the way, guys, I'm going to send a sign-in sheet again because it is the next hour, so we need you to sign in.
Uno
Por
más.
favor.
What's something Spanish? We're on the same wavelength. That's
You catch
scary to
that
think
vibe?
about.
You catch the vibe.
Got a vibe.
Right.
Okay.
I'm gonna stop.
Are you though?
No,
Okay, good.
for being honest.
Sorry, they're margaritas. I thought you said they're margins though, because I've been watching a lot of Grey's Anatomy, and I was like, margins? What? Yes. We're gonna just have a party at the end of the semester where all 300 of us are gonna pile into one room, and Katrina's gonna make 300 margaritas.
It's like 4 glasses.
Well, you better bring some time. What am I saying? Ignore me.
By the way, guys, I'm not going to do anything extra for chapter 17. We're just going to do the handout, and I'll post my guide on Canvas over the next couple of days, and I'll go over it with you guys in SI on Monday.
Queen
Okay.
behavior. Truly.
Anything that wasn't in this review that you guys need to know for Roche, we'll just do it on Monday during SI.
Swag. We love to see it. Okay. Because people kept asking for it.
I don't think I've seen anything that are super difficult from chapter 17. It's just that some reactions from previous chapters come back to bite us in the buttocks. Like our Friedel-Crafts reactions and things like that, at least from what I've seen from his exam like summary. So I'm gonna try and see exactly what he means from that summary based on the review questions he gave us. But yeah.
Okay. So hopefully everyone got a chance to kind of like chill. I don't like cinnamon either.
Yeah, I'm not a huge cinnamon fan. I like the smell of cinnamon,
Yeah.
but I won't consume it. Do you have a date for your other exam review? No.
No, but also I read that and I was sitting here like, what is a personal review and why do I need a date to it? And I was just like sitting here, I was like, what? I'm a little bit slow today. No. So I don't know. I'm trying to figure my life out.
Same.
For next week. Yeah, I'm so sorry. I'm so not helpful today. Yes. It's almost Christmas time, so
Okay, I've only had that once, and I think when mine was slightly expired, so it did not taste great. So if you have one, hit me up. Hit me up.
everybody better show up. Yeah, never mind.
And my birthday's in December, so you know
My
I'm getting
birthday's in
lit.
November. When's your birthday?
The 16th.
Wow.
Do it. Okay.
Anyways, okay. I wanted to give y'all a little bit of a break. Let me hold on. Nope, stop it. Okay.